So next we're going to discuss about the OSPF designated router DR and the backup designated router the BDR. So OSPF is open shortest path first. As we know, this is a link state routing protocol and it has the LSA, that is a link state advertisement that it sends to every other router in the network. The network can be of any type. It can be point to point, it can be point to multi-point, it can be broadcast network or non-broadcast multiple access. But in every network, there is possibility of LSA flooding. So in an area, inside an area, all the routers exchange the LSAs and it creates a lot of traffic. So we must understand the process to eliminate this flooding. So we will explore the roles and functionalities of designated router and backup designated router in OSPF. So what is the DR and BDR? DR and BDR plays essential roles in optimizing the OSPF network performance. Means that if there is too much LSA flooding, then there will be bandwidth limitation. So the network will be slow. So to preserve the bandwidth, we must use the DR and BDR concept. Now DR and BDR is a logical concept. And by minimizing the amount of routing information or the LSA, that is the multicast updates among the routers, they enhance efficiency and reduce potential network congestion or bottleneck. Because in any area, if you add the number of routers, if you keep on adding the routers, then with that, the network broadcast traffic or the LSA will also increase. So particularly in broadcast and non-broadcast multiple access in BMA environments, we use this DR and BDR. DR and BDR is not used in case of point-to-point links. That is the point-to-point networks, because in point-to-point networks, there is very few nodes. There is a provision of very few nodes. Like if you go for the formula like n into n minus 1 by 2 to know the adjacencies, you see that in a point-to-point direct link, if there are two nodes connected directly, then there is very little LSW that is going on. So we do not need any DRBDR there. So how the DR and BDR are selected? If some routers are connected, the concept is that the neighbor routers will only send the updates to the DR and BDR. They will not send the updates to themselves. And DR BDR will pass on these updates to the other neighbor routers. But how the DR BDR is elected? The election process actually happens when the router is starting, when the router is running. In a runtime, it never happens. So what is the step one? Step one is router priority. That is the first condition. So routers are assigned a priority value and higher values are preferred. So if you use IP-OSPF priority, then you can assign the DR and BDR role there. Like the router having the highest priority will be DR, the second highest will be BDR, that way. But generally, we do not do that because priority is equal in every router. So we go for the router ID, the step two. In cases where router priorities are equal, then the router with the highest router ID is elected as the DR. And highest router ID means you can assign the router ID manually, but in case of OSPF v2, we do not do that always, because in OSPF v2, what happens, the router takes the serial port IP address or any Ethernet port IP address that is the highest IP address as its router ID, that is from the physical interface. So the router having the highest router ID, that is the IP address, will be elected as the DR, and the second highest will be the BDR. And step three is election process. All routers in the OSPF network, they participate in the election process to determine the DR and BDR. And as you know, the routers, the neighbor routers, will send the LSAs to the address 224.0.0.5 to communicate with between themselves. But to the DR and BDR, they use different address, that is 224.0.0.6. So this is step one, the router priority. You have to decide, you have to assign a priority value. Higher priority values are preferred. Number two is router ID. In cases where router priorities are equal or it is the same, then the router with the highest route ID will be elected as a DR. And step three is election process. All routers in OSPF participate in this process. So this is about the DR and BDR election process and the theory behind the DR and BDR, and the rest is all practical. So let me now take you to the Cisco packet tracer, and let me take a switch. This is a router. Let's say this is the DR, and this router should be BDR, and any other router will be considered as TR other or any other neighbor router. But we should not add many routers to this packet tracer, because otherwise what happens that in simulator environment you have to restart the routers again and again, because otherwise the incorrect IP address and the router state is shown. So we must take minimum the two routers. So to understand the DR and beta election process, so only with two routers it will do. So let's connect it with the sled cable. First give the IP, let's say interface 0 by 0, shirt, IP address, say 10010, and in the other router, that is BDR, IP address, let's say 1009, and then start the OSPF process on both the routers, router OSPF, and the process ID would be 1 65535 between that. So you just select the process ID, say 1, and the network statement 1.0.0.0.0.255 area 0. And on the BDR also the same thing. Process ID, it can be 1, it can be 2, it can be anything. Or an area 0. And you have to save it with write command or copy and start, and you have to reload both the routers, because when the routers are reloading or they are starting, then the DRBTR will be elected. You can reload it with reload command or by going to this physical and switch off and switch on this interface. So I'm reloading it here. Let the OSP process be started. And now the OSP is started, and let's check the DRBDR status with show IP OSPF interfaces. The Ethernet router you can see as 10010, that is the highest IP address, and backup is router as 1009. So the highest IP address, the router is selected as DR, and the second highest is already BTR, and the you can see the state is DR, and the priority is 1. By default, it is the 1 priority it has taken. And on BDR, show IP OSPF interfaces, and here the state is BDR, and the router ID it has taken as 1009. So the reason router here also is 10010, and backup is at 1009. And if I check the show IP protocols, then I can see the OSPF router ID is 1009. Now, if I need to change this router ID, how can I change it? You can go to the router OSPF to, and can you change it here? Yes. Give just router hyphen ID, and A.B.C.D means in the IP address format. I can say that I'm giving router ID as 10.10.10.10, but it will not take, otherwise you have to use reload or use clear IP OSPF process command. So I don't need to reload it, because otherwise then the whole OSPF process will be reloaded, the whole router will be reloaded, then the other services may be affected. So I will use clear IP OSPF process command. Reset all OSPF process, yes. So it is actually resetting the adjacencies, and then it will take the router ID. Again, you can see the OSPF, the neighbor relationship is updated. And if I use now show IP protocols, you can see the router ID is updated with 10.10.10.10. So this way we can elect the DRBDR, and also we can change the router ID of the OSPF router. So that is about the DRBDR process, and I'll see you in the next video.